Chapter 2, Describing your data, frequencies, crosstabs, and graphs. Researchers use a variety of different methods such as surveys, interviews, experiments, databases, and so on to gather empirical data. For example, I'll give you one out of these. A sociologist might gather data on cultural norms. Empirical data. The actual definition is data gathered from objects or participants for a research study. And check out that little funny picture I have in the corner. So funny. Frequency refers to the number of observations of a specific value within a variable. So in this little picture I have here underscores, you see a tally of 1, 1, 2, 2, 2, 2, and 3, 3, 3, 3. Those are frequencies. A frequency distribution is a summary of the values of a variable based on the frequencies with which they occur. So this picture, you know how it says score? That's the coding 1, 2, 3, 4, 5 in order. Then on the right-hand side, that is distribution. And then relative frequency is a comparative measure of the proportion of observed values to the total number of responses within a variable. This pretty much just gives you the percentage. So you know where it says frequencies? You just add 2 plus 5 plus 4 plus 2 plus 1. And that's going to equal 14. And that 14 you would plug into the N, which stands for population. And then F is whichever frequency you want to check out. Let's say we want to check out the one for coding 1, score 1, which is frequency 2. So you would just divide 14 with 2, and that will equal 7. So that's 7% for that one. So pretty much all a relative frequency is how often something happens divided by all outcomes. I'll give you another example. Let's say your team has won 9 games from a total of 12 games played. The frequency of winning is 9. The total is 12. So the relative frequency of winning is 75%. You would just divide 9 by 12. When you do the division, you are probably going to get a decimal. You just multiply that by 100 to get the percentage. So I'm going to explain what each and every single label means. A class interval, it's also known as group frequencies. The name speaks for itself. We're just grouping, the frequencies. It's like 42, 49, that's a group frequency right there. And this just makes it easier for the person to read. It's more useful, opposed to having like each frequency, like say instead of 42 to 49, they put like 42, 43, 44, 45 like in a list. It just takes up too much time reading. Class limits are the starting and ending of each value. So for the first class interval, the starting is 42 and the ending is 49. So even though that you have class intervals that are exclusive of one another, you still may have observations on the boundary of two class intervals. Like for example, if your class intervals were 40 to 49 and 50 to 57, where would you put that 49.5 if it existed in the data? Would it go in the first class interval or the second? You can see that there is a gap between the limits between 49 and 50. So basically, to solve this, all you have to do is subtract 0.50 from the lower class limit and add 0.50 to the upper class limit for each class interval. The boundaries do not have a value separating them like class intervals do since they are continuous. Therefore, our class boundaries are 41.5 to less than 49.5. 49.5 is less than 57.5. 57.5 is less than 65.5, and 65.5 is less than 73.5. Thus, the value 49.5 would go in the second class interval, which has the boundaries of 49.5 less than 57.5. So the midpoint, that's the average value of the class interval. It is often used as a rough estimate of the average case in each interval. That you calculate by adding the lower and upper limits together and dividing by 2. Therefore, the midpoint for our interval for the first one is 45.5 because you take 42, you add it with 49, and you divide by 2. It's really easy. So relative frequency, we already went over. That's just the frequency divided with the population. Percentage frequency, we went over as well. You just multiply that by 100 to get the percentage. So the cumulative percentage frequency gives the percentage of observations up to the end of a specific value. And how you get these are you take the percentage frequency on the left, you start off with 20, as you can see, and then you add what's on the bottom of that 20, which is 25, and that will get you 45. And then add that 45 with the 25, that will get you 70. 70 plus 30 will get you 100. That's how you get the cumulative percentage frequency. Class intervals must be exhaustive, meaning they must include the entire range of the data and must be mutually exclusive, which means the class widths are unique enough that an observed value can be only placed in one class interval. And also how you get the range is you take the lowest number and you take the highest and you subtract those two and you'll get 31, and that's how I got the range. So next, since we want the width and number of class intervals to incorporate all of the data, we divide the range of the data by the number of class intervals we would like to have, and if necessary, round up to the next value. So let's say if we opt for like 4 class intervals, the width of each interval is 7.75. And how I got that was I divided 31 with 4 and I rounded up to 8. So with the width of 8 for each class interval, our intervals are, as you can see, 42 to 49, 50 to 57, 58 to 65, and 66 to 73. So the class boundaries, I already explained that in the last slide, so I don't need to go over that. So I went over the midpoint already too. You're just adding 42 and 49, so the upper and lower limits, and you divide by 2, and that's how I got those answers right there. Cross tabulations. Whereas frequency tables display a summary of the distribution of a single variable, crosstabs displays a summary of the distribution of 2 or more variables. The difference is that crosstabs allows you to observe how the frequency distribution of one variable relates to one or more other variables. It tabulates the frequencies by the categories or class intervals of the variables being compared. So let's talk about the percentage change. There's the formula up there, and I have an example below about violent crimes in BC from 2010 and 2012. Grab your calculators, and what you do is you plug in the formula up there, down there. It's really hard to explain this way, but I'm sure you guys can follow along. So you take 63,885, which is time 2, and you subtract time 2 time 1, which is 71,138, and then you get your answer, and you divide by time 1 again, and then you multiply by 100. So pause the screen and get the answer. And did you guys get it? The answer is minus 10.19, which means the crime rate went down 10%. So ratio you've been pretty much doing your entire life. I don't really need to go over it. They just added a fancy formula. Frequency variable 1, frequency variable 2, you're just dividing it, and that's how you get the ratio.